Today we're going to be talking about the real number system, and we're going to be using this graphic organizer to help us to learn it and study it. We're going to begin with the very small circle here. When we're young and we're just learning how to count, we learn with starting with the number 1 and then 2, 3, 4, etc. So literally these numbers inside here are called counting numbers. You might also refer to these as natural numbers. And again, this is just like a little child starting out. When they're young, we start teaching them to count blocks, and we say 1, 2, 3. And so that is how we start with our real number system. 1, 2, 3, and it would go on from there. As we get a little older and we go to school, kindergarten, we start learning that there's another number involved with our in front of the number 1, and that would be 0. So now we have whole numbers. The way you can remember these are whole numbers is the 0 or the O here. This means 0. So if you think of the O meaning that we include 0 when we describe our numbers now. Key thing to keep in mind with our whole numbers is we have no fractions here, and we also have no decimals. So the only difference between a whole number and a counting number is the fact that now we have 0 in front of our counting numbers. As we continue along in school, we start middle school, and now we learn that we also have negative numbers along with all of our whole numbers. So we are calling these now integers. You want to think of integers as being those numbers that we actually have on a number line. So these numbers are on a number line. I should say on a traditional number line, because any number can be on a number line. We can graph even half on a number line. But on a traditional number line, we would just have all the whole numbers and all of their opposites. So if we start with 0, 1, 2, 3, these would be our whole numbers. And then we would have all the opposites of those whole numbers. So now we would also have negative 1, negative 2, negative 3. Again, to keep in mind here, this is a traditional number line. So we're talking about the whole numbers and opposites, no fractions. So we still have, with our integers, we have no fractions in here. And again, we have no decimals. Also, a way to think of this is they are all of our positive and negative numbers. And again, we know that we can have a negative fraction, for example. So we want to be thinking about it as in terms of whole numbers. That would be all your positive whole numbers and their opposites. Because those would be the negatives. And again, as we demonstrated in our number line here. So again, as we move out, our numbers are getting more and more complex. So our last thing here is our rational numbers. The key word here with rational is ratio. So you should be thinking, can I write this number as a ratio? Another way to think of that is, can I write it as a fraction? Oops. These also include decimal values. So here is where we finally have our fractions and decimals. These are decimal values that end, or they might repeat, like a repeating decimal. So those are our rational numbers. Any kind of number that ends, any decimal number that ends or that repeats. For example, 3.5. There's a decimal value that ends, or I might have 0.66 repeating. The bar across the top, remember, it means to repeat. Also, again, fractions. So we could have 1/7. Or we could have 2 3/4. All of these would be our rational numbers here. We also have something called irrational numbers. That's what we're going to put in this column here. And a lot of people kind of think of anything that's irrational as crazy. So you can kind of think of these as your crazy numbers. The reason why we're calling them crazy is because our decimal values never end, and they also never repeat. So, for example, one of the most famous irrational numbers we have is pi. We say that pi is 3.14. However, we know that that number actually never ever ends, and the numbers never repeat. By repeating, we're talking about repeating in a certain pattern, like 1, 2, 3, 1, 2, 3. That would be repeating decimal, which would then put it in our rational category. But it's irrational because, again, the decimal value never ends and the decimal value never repeats. Okay, from here, this is what it should look like. And again, all of our numbers on both sides here, in this box and in this box, all of our numbers are real numbers. Every one of them are real numbers. So that's something to keep in mind. From here, we did our graphic organizer again to show the real number system. Just making it a little bit neater and a little bit of color to help us to remember. So again, natural or counting numbers, whole numbers, integers, rational numbers, irrational numbers. One thing to keep in mind is if you think of focusing in on something, if I'm looking only right here, these are my counting or natural numbers. An integer is not a counting number. However, a counting number is an integer, because if I zoom in just on integers, counting numbers is part of my integers. If I zoom in on whole numbers would be starting with my 0, 0, 1, 2, 3. But also counting numbers are whole numbers because they have the 1, 2, 3. If I was talking about rational numbers, that would include all of my fractions and decimals that either repeat or end, all of my integers, all of my whole numbers, and all of my counting numbers. All of these things are also rational numbers. If I'm talking about irrational numbers, they're strictly over here. Any irrational number, for example, integers are not irrational, and irrational numbers are not integers. So you have to kind of think of those types of sayings. All of the numbers, again, every single number that you see on here is a real number. It is part of the real number system.